Hey YouTube, in this video we're going to be trying to figure out what the longest rook checkmate is. So here's an example of checkmate on the board. The white king covers the three squares in front of the black king and the rook sweeps out the back rank. And whenever there's a king and rook versus a king, it's always a win for the side with the rook. So no matter what position these pieces are in, white can always eventually force a checkmate by doing the same sort of thing, cornering black to an edge and then delivering checkmate. So every position with two kings and a rook has basically a forced checkmate in X moves. And we're going to try to find out which position has the highest possible value of X and what that value is. So we'll quickly go through an example here. This position on the board with white to move is a mate in 5. And that means this game will always end in 5 moves if both sides play perfectly. So white playing perfectly is trying to deliver checkmate in as few moves as possible, and black playing perfectly is trying to survive for as many moves as possible. So essentially, white plays king e3, and black only has 2 options. The second rank is covered by the rook. Going back gets mated immediately. So black will have to continue down the line here, and white will basically just keep forcing the king down the line. Black can never go back. White continues down the line. Black is forced into the corner. And here black is finally out of moves and gets checkmated on b1. So if we go back to the original position, we can see that this will always evaluate as mate in 5. And if it's more, that just means white didn't play perfectly. And if it's less, that basically means black didn't play perfectly. But assuming perfect play, this position evaluates as exactly a mate in 5. So as you could probably imagine, that example we just went over was a pretty good case for white. The black king was already on the edge of the board and white was just a couple moves away from checkmate. But most positions are not going to be like that. For example, the one on the board here, the white king and the rook are not coordinating very well. The black king can centralize easily. This is going to have a much higher forced mate in X value. And we really want to try to find the longest possible one. So I'm about to go into the solution part of the video now. So if you want to try to solve this on your own, I'm just going to go over a couple nuances. So basically the pieces can be in any configuration, minus a couple exceptions. Obviously the position has to be legal, so you can't have something like adjacent kings, or a rook that can immediately capture the black king. Also either side can move to start. So you can't have a position where black can immediately capture the rook. Like something like this with black to move would not be allowed, because that's a draw, because black can immediately capture the rook. And the last nuance is you cannot start in a position that's immediately stalemate. So if we had something like this position with black to move would be stalemate, which is a draw because it's black to move. They're not in check, but they have no legal moves. But yeah, aside from those few exceptions, any position is completely fine, and either side to move to start is also completely fine. So the way I'm going to go about solving this problem is basically in 2 stages. I'm going to first generate every position and then categorize all of them. So I'll basically have a couple giant loops where I'm placing the black king on every possible square. And then with the black king in every position, I'll place the white king in every square. And then with the black king and white king in every position, I'll be placing the rook on every possible square also. So obviously this is going to generate a pretty large upper bound. As you can imagine, the black king would have 64 squares to start on originally. The white king could go into any of the remaining 63. And then the rook could fall on any of the remaining 62. And then the final stage is in any of the positions, it could be either side to move to start. So that would be times 2. So 64 times 63 times 62 times 2 is right around 500,000, I think just under. And as you could imagine, a lot of those positions are not going to be legal. There's going to be things like this with adjacent kings. So the first step in categorizing the positions is filtering out all the bad positions. So first removing anything that's illegal, like adjacent kings, immediate king capture or rook capture, and stalemates, as we talked about earlier. And then once we've gotten rid of all of the garbage positions, we'll be left with all positions that we can be sure evaluate as some sort of mate in X type value. So there's two things we can do to make our lives a lot easier. First, we can separate the positions based on whose turn it is to move. So positions where it's white to move and positions where it's black to move. And also, we're going to measure all of the mating depths in half moves, which basically means a single side moving instead of a full move, which is both sides moving. It just makes it easier to categorize, and the direct natural result of that is any position where it's mate in an even number is going to be black to move, and any position where it's mate in an odd number is going to be white to move. This is just simply by the fact that white is the only side that can deliver checkmate, and that would always be in, essentially 1 or 3 moves. So just looking at what we have, you could probably imagine that the mate and 0 positions are going to be the easiest to identify, just because checkmate is currently on the board. That's what mate and 0 would mean. So any position where black is in check and has no legal moves is pulled from the unsorted category and moved into the mating depth structure. And now identifying the mate in 1 positions is easy, because any position where white can play a move that transitions into a depth 0 state has to be mate in 1. So we can move these positions from the unsorted category into the mating structure. So now comes the tricky part. Identifying the mate in 1s was easy because white wants to be a part of the mating structure. So even if just a single move will get them there, that's good enough. But black has the exact opposite goal, so identifying the mate in 2 positions is a little harder. Every single one of black's legal moves must exist somewhere in the structure for it to be mate in 2. Otherwise, black will choose a move that doesn't and delay the checkmating further. So a faster but seemingly backwards way of thinking about this is to check if black can transition into any of the unsorted white positions. Because as soon as we find just one, we know the position is not mate in 2 and we don't need to check the rest, similar to why checking the mate in 1s was easy. If none of black's moves transitions them into an unsorted white position, then we have to assume that all of them already exist in the mating structure and black's position is forced mate in 2. So mate in 3 is really just as easy as mate in 1. If white can transition into mate in 2, they will transition into mate in 2. And mate in 4 is pretty much the same thing as mate in 2. If black can transition into any position in the unsorted white category, they will. Otherwise, they're forced into the structure. So you can see how we can basically just alternate back and forth between black and white until all of the unsorted positions have been categorized. Then once this structure fills out, we'll have a deepest mate in X category, and that's when we know the answer to our question. So I don't want to waste too much time talking about the code because it does essentially everything we just talked about. But one thing I will say is that I wanted to try to solve this without using any third-party libraries. So if you were doing this problem on your own, I would say something like a chess library would be fine, but obviously something like an engine or an endgame table base would be cheating. But in my opinion, the overhead just wasn't worth it because pieces like the king and rook move simply enough that there's really not too much you need to check for manually. So I figured I would just do it on my own. So yeah, generate positions does exactly what I talked about. It places all the pieces, it filters out all the garbage positions, and then it prints out some information, and we go into the solve file next. There's a bunch of utility positions here, but I don't want to bog you guys down with this. I'd prefer to just get straight to the solution. So all of this code will be on GitHub. I'll put a link in the description if you want to check it out. It's all commented, and if you have any questions, you can look there and ask. But for now, I prefer to just show what happens when you run it. All right, so before I run the code, I just want to mention that going into this problem, I actually had no idea what the answer was. And even after I solved it, it took me a while to find a source that I could use to verify that my answer was correct. So comparing that to, for those of you who have seen my 2x2 depth solution video, that was a problem I had known the answer to for years. I just wanted to solve it to see if I could verify. But this one was cool because I was actually solving a problem that I didn't know the answer to. And if you haven't yet tried to solve this problem, I would definitely suggest that you do it. Comparing those two experiences, I got to say that it was much more rewarding to solve a problem on my own and then learn that that answer was correct than it was to know the answer to something and just simply verify that I could do it. All right, so here we go. So the first thing it does is just calculate that upper bound, about 500,000 positions total, of which you can see about 100,000 are illegal, and 22,000 have the ability for the king to capture the rook. 68 stalemates, and now it's basically just calculating all the different moves that can be played in all the different positions to figure out which can transition into each other. And once it gets through that, it'll start to identify the mate and zeros and work upwards. So as you can see, there's 216 mate and zero positions, and it's now able to logically stack the other depths on top of it. And as fewer and fewer unsorted positions remain, it'll start to accelerate the rate at which it can calculate because there's fewer things to check. And you'll see that as it goes through here. So as you can see, that's the answer. White can always checkmate in 32 half moves or less. And of course, 32 half moves is the equivalent of 16 full moves, which is probably the more common way of seeing this result displayed. But yeah, that's essentially the answer to the question. So here, this is the closest thing I've been able to find to verify that my result is correct. This is just a table of common endgames and what the result is. So you can see the one with the white rook is the attacking piece and the black king is the defending piece. The longest win is 16 full moves, which verifies our result. But of course, I would like a little more than this. I want to know for sure that the numbers I found at each of the depths are correct as well. So if any of you are able to find any sort of source that can verify those numbers, please feel free to let me know in the comment section. I'd like to know for sure that they're correct. But for now, knowing that the answer to the problem is correct is good enough for me. So yeah, that's it for the video. I'm sure some of you are curious what some of these deepest positions are. So I'll list a couple of FENs in the description to give you a few examples, but there are 3,000 of them and none of them are really too special or unique. But I'll show you anyway. So if you enjoyed the video, please feel free to like, comment, and share. And of course, if you want to see more content like this in the future, consider subscribing. Thanks for watching.